So I see that Abdel has joined us,
Hello,
and
can
hello,
you hear me?
hello Abdel. Hi, thanks for coming.
Thank you very much for inviting me. I'm very happy.
It's a pleasure. So I'll start in a couple of
Okay.
seconds. So hey, brothers and sisters from the Starknet ecosystem, welcome to the Star Cafe, a virtual space cafe where you'll enjoy some good quality content about Starknet, brought to you by Nurstar, your personal Stark barista. So guys, today I have the pleasure to brew some good coffee for our friend Abdel, exploration lead dev at StarkWare, who will introduce us to the latest open source project that is being experimented in the Keep Starknet Strange GitHub repository. And I'm talking about Madara, a Rust-powered Starknet sequencer. So first of all, let's welcome Abdel. Hi, Abdel. How are you?
Hi, I'm fine. Thank you. Very happy to be there and have the opportunity to discuss about Madara.
My pleasure. Very excited to hear this episode. And well, Abdel, explain to us what Madara is and how this idea to build a Rust sequencer for Starknet came up, please.
Okay, sure. So basically, the original idea, we are starting to gradually move our technological stack to Rust. So it started with Lambda class implementing the Cairo VM in Rust, and then progressively we started to switch the infrastructure to Rust mainly for performance reasons. And now we are in the process of starting to build the sequencer. So just a reminder about what is the sequencer. So basically on the validity rollup, the sequencer is the entity that is responsible of producing blocks. So basically that means executing transaction and then batch them, validate them, execute them, and then produce block. And then those blocks will be proven asynchronously by the prover, and then the prover will submit both the proof of execution and the state diff that will be sent to the Ethereum L1 contract. So basically, the sequencer is a very central entity in the network. It is very important because it is what will give the throughput of the network and also how fast will be the blocks and the inclusion of transactions. So this is a very important piece of the architecture of a validity rollup. So we need it to be very fast and very performant. That's why we start to try different approaches basically to implement this sequencer. Basically, there are multiple options. We can do it from scratch. That means build everything from scratch, including the storage, networking, the peer-to-peer consensus stuff, etc. Or we can take an existing piece of software that enable us to use battle-tested primitives that will save us some time and enable to leverage what has been already done by others. I'm exploring this option. So Madara is exactly this. The idea is to leverage Substrate. So a few words about Substrate. So basically Substrate is a framework or an SDK that enable developers to build their own blockchain very easily. So it has a very modular architecture. The idea is that you can take some components, so the components in Substrate terminology are called pallets, and the pallet is a custom blockchain logic of the protocol. So you can take existing pallets. For example, you can use a pallet that handles some voting system. You can take a pallet that handles staking, NFT, whatever you want. And for your custom need, you can implement them as new pallets. So this is exactly what we do with Madara. we want to focus for the moment on the execution of Starknet transactions. That means we created basically a custom palette to do that, but I will maybe explain later about more in details about the architecture. But yeah, this is a general idea of Madara. So it can be a candidate for to become the public the canonical sequencer of public Starknet. It's not sure yet that it will be, but it has the potential. At least it is a candidate. But at least even if it does not become the sequencer of the public Starknet, it will be usable for app chain or layer trees. But again, I can explain more later on that front as well.
Very well. Thanks a lot, Abdel, for brushing up the concept of sequencer first, and also to explain to us the idea behind Madara, and also telling us the role that Substrate plays in all of this. And right now I'm scrolling down the GitHub page of Madara, something that I also suggest our listeners to do. And I'm seeing its architecture. So I'm seeing that Madara is composed by, especially by some components. There are node palettes and the runtime. Could you elaborate a bit deeper on that, please?
Yes, for sure. Okay, so basically the architecture is the following. In Substrate, there are multiple components, basically. You have the runtime, which is the main piece of the Substrate architecture. So basically the runtime is responsible of executing the palettes, which are on-chain execution. So basically the runtime, you can see it simply as the box that will be responsible of doing the state transition function. You know, in the blockchain, you have the state, then you execute some blocks and you get another state. Basically, how you get this new state is you apply a state transition function. It can be many things. So, for example, it can be an EVM, it can be a Starknet OS, etc. So the idea of the runtime is really to execute the state transition function and enable to get the new state of the blockchain. So the runtime is the central piece that coordinates the different palettes and execute them, to get the new state function. Then you have the palettes. Like I said, you can take existing palettes or implement your custom palette for your needs. This is what we did for Madara. I will explain in details exactly what this palette does. But before, I will explain the other part of the architecture. So you have then the client. So what is the client? It basically, in Substrate terminology, it is called the client outer node. And basically, it means it is responsible of everything that is not the state transition function, like interaction with the outside world, like basically, for example, the networking communication with other peers in the network. The outer node is also responsible of storing information, the RPC layer. You have also some telemetry. So telemetry is how you can monitor your node based on different metrics, like, for example, CPU usage, memory usage, stuff like that. And then you have also, some part related to the consensus. But basically those are the three main pieces in Substrate architecture. The client outer node with the external world communication, the runtime that runs the palettes, and then the palettes. One cool thing about that is that basically the runtime is a WebAssembly runtime. So for people that don't know WebAssembly, you can see it basically as a very portable representation of a program that can be run in many different kind of architecture, including a web browser, for example. And it is very flexible. And because Substrate has this WebAssembly runtime, it enables you some very cool features, like, for example, the code of the state transition function is actually compiled in WASM. So that means you can do some what they call forkless upgrades. So, for example, basically in a traditional blockchain, if you want to do a network upgrade, for example, you will need to coordinate and ship a software, and then all the nodes will have to update their software and then coordinate and run the new software, etc., etc. But with this WebAssembly runtime, you don't have to do that, because basically you can do an upgrade on one node, for example, and have a mechanism to determine how to allow upgrades, obviously, because you don't want anyone to be able to trigger an upgrade on the network, but you can couple that, for example, with some voting-based mechanism. For example, let's say, and this is what we do currently, for example, for Starknet, there is a vote and people vote to accept an upgrade or not. But with that, you could actually do the actual upgrade based on this vote. Not only, because for example, here you need to trust that humans will actually do the upgrade if the vote is yes. But with Substrate, you can imagine a system where once the vote reaches the majority of yes, automatically the upgrade can be triggered on-chain and without any intervention from nodes operators, because thanks to the WebAssembly runtime. So this is very, very powerful. It also comes with some constraints for sure. But yeah, I won't go into the details, into the specifics, but you cannot take any existing Rust project and convert it to a Substrate palette because of that, because it needs to have a specific limitation, that is to be able to run without the standard Rust library. But anyway, it's a technical detail, technical implementation detail. So yeah, I can tell more about the Starknet palette. So the Starknet palette, basically, it is responsible of handling Starknet transactions. We have roughly three main types of transaction. Declare transaction, where you actually declare a new code for a new class, and then you have the possibility to deploy an account, and then you can also obviously invoke a transaction. Those are the regular transactions you do when you interact with a smart contract. So we have those three transactions that are accessible in the palette. And then basically the idea is to package, to bundle the blockifier. So the blockifier is a repository that is being developed by StarkWare internally. And the idea is that it has the core logic of the sequencer. That means the actual execution of Starknet transaction. So the blockifier itself bundles the Cairo VM. So this is very modular approach, basically. So we have Madara that implements a Starknet palette that integrates the blockifier that enable to execute Starknet transaction and implement the syscalls that are present in the Starknet OS, and then uses the Cairo VM to do the actual execution. I will do a stop there because I talked too long, but yeah, that's the overview of the architecture. Does it make sense?
Yes, it does, indeed. Thanks a lot for this great explanation about the architecture of Madara. Right now, before asking you for the last question, I would also like to invite the other contributors of Madara to the space. So feel free to send me a speaker request if I've not sent you one yet. And the question for the last question is like, although you already gave us a spoiler on the future role and possible role of Madara, I would like to know how Madara relates to the current Starknet sequencer, how it relates to the concept of L-trees, and how does it relate to Kakalot, if it could relate to Kakalot at all, and this kind of relation. I would like to know this from you.
Okay. I will let first Matthias speak. Matthias is a very active contributor on Madara, and actually he will give part of the answer because he has some very special need related to Madara. And I also invite Davide to speak if he wants, because he is also contributing to Madara. Please go ahead, Matthias.
Hello, hello everyone, and thank you, Nerstar, for for inviting me to speak. So, indeed, I think Madara is a very, very exciting project, and I've been working on it from pretty much the beginning now. And yes, there are a lot of different use cases enabled by Madara. I wasn't there at the beginning of the space, so I don't exactly know what Abdel you talked about already. But on our side, I'm very excited about the possibilities of future L3s that Madara enables. And why did we decide to go with this architecture? It's mostly because Substrate is like very, very generic in itself. So Substrate doesn't force you to, in any design choice when you're designing your app chain, like it doesn't force you like to use a specific account ID type, a specific hashing function, or anything. It's all generic. So when you're creating your app chain, you can just try out different hashing functions, different types of storage layout, for instances, and that's very, very powerful, right? Especially when it comes to L3s and when you have when you want to design something that is very customized for your own need, that is very powerful. Like even you can easily try different consensus algorithms. So Starknet hasn't decided yet on which consensus algorithm is going to be used, but on the layer on top of it, we can already start testing out and making some design choices. So at Pragma, we basically want to leverage Madara to build our own L3 that will be that will be optimized for many things. We want to change a lot of things you can think of it as a custom Starknet, but like with a different storage layout, with a faster consensus, because we're not be a general blockchain, but more like an app chain. Those are the main things. And of course, for instance, slashing is like very easy to implement on a Substrate blockchain. Whereas if we were to design some kind of off-chain network or thing like that, it would be way harder and even more opaque, which is something we really don't want. I think that sums it up pretty well.
Great, thanks a lot, Evolve, for your explanation and views about Madara. Abdel, would you like to add something, or shall we proceed towards the closing time of the Star Cafe?
I can add a few words on that. Even though Matthias did a great explanation on that. But yeah, as I said, Madara is a very serious candidate to become potentially the sequencer of the public Starknet, but it's very cool because even if it does not become, it will still be usable by layer 3, app chain, etc. So we are discussing with many projects, like Matthias, who is actively involved in Madara for Pragma Network, but we are also discussing with Dojo, which is a kind of a framework for game developers to easily run some gaming project on Starknet. So we are discussing with them on how to use Madara to have a fast app chain that will enable games to be actually usable. So hopefully in few weeks we'll be able to have a first public testnet of Madara that will showcase some interesting stuff. I won't say more about that for the moment, but please expect to hear more about Madara very soon. And it's only the beginning. Matthias, you wanted to add something before I continue?
I mean, as you mentioned, the great thing is that we're not the only one that cares, that sees in Madara a lot of potential. As you say, there is Dojo, there is Sad Pragma, there is Kakarot, I think. There is even people from Giza, so working on AI, on-chain AI inference, and many more. Like, yeah, once we start to showcase something that actually works and that people can easily customize to their needs, yeah, I think we will see more and more people thinking about new ideas and new, yeah, just new innovation that will be able to arise from Madara. So that is very, very cool.
Awesome, guys. Thanks a lot. I'm really looking forward to the further developments of Madara. And right now, we've now come to the closing time of the Star Cafe, where, as you know, we talked about Madara, the Rust-fueled Starknet Sequencer, that is going to play an amazing role in the scaling concepts of concepts of Starknet. And I would like to thank the guests, first of all. Thanks, Abdel, thanks, Machas, for coming today. And then I would also like to thank all the listeners for taking some of your time to be here with us. So thanks a lot, guys. And see you on the next episode of the Star Cafe.
Thank you. Goodbye.
Thank you very much. Bye.
Bye, guys. Bye to everybody. Take care.